Hi class, welcome to Chapter 11. Chapter 11 is titled Sequences and Series, and on 11.1 and 11.2 we're going to be talking about sequences. And today is an arithmetic sequence. So let's first define what a sequence is. A sequence is simply a list of numbers, okay? But they're in a particular order. So the order isn't random or by chance, it is very particular. There's a certain pattern about that order. Okay, so here's what a term is now. Whenever I say a term, it's each number in a sequence. Here's the first term. Here's the fourth term. Here's the, third term, whatever the case might be. Okay, each of those are terms in the sequence. So now, to really define what an arithmetic sequence is, pay very close attention to this, class. An arithmetic sequence is a sequence in which each term is found by adding a constant called the common difference to the previous term. So this is an arithmetic sequence because I am adding a certain number every single time to get to the next one. I am adding 2 each and every time. So that 2 right here, what I'm adding, that's called the common difference. It's abbreviated using the letter D. Okay? Now I just want to touch on one thing with you. If I were to have like 18, 15, 12, 9, this is a sequence. What's that common difference? I don't want to hear you say, Mr. Berge, that common difference is subtracting 3. Okay? The reason why is because the common difference is always found by adding. So it's adding a negative 3. I know we're subtracting 3, but I want you to think about it as adding a negative 3. Because that's going to tell us that it is arithmetic when we add. So we're adding a negative 3. So that's why I want to touch on that using the common difference. Okay, so for this next one, some Excel math questions are seriously this simple. Okay, find the next 4 terms in the sequence. Well, how do you get from here to here? You have to add 3. How do you get from here to here? You have to add 3. So what are we doing to get each and every term? We're adding our common difference of 3. So then we have 1, 4, 7, and 10. Really basic, right? We do have some Excel math questions that are quite that simple. Alright, we also have ones that are more difficult, in which case we're going to use these formulas to help us out. Okay, especially this one, this explicit formula. I'm going to talk about how to use it in later slides. This one I'm just going to talk about each and every one of the letters. So we've already talked about the common difference. That's our letter D. Okay, so that D is found by adding the D is the common difference. So it's the one that's added to get each and every term. Okay, I'm next going to talk about A sub 1. A sub 1 is the value of the first term. So let's just say I start at 25, 30, 35, 40, 45. Okay? The first term is right here. The value of the first term, so notice how A sub 1 is a value. The value of the first term is 25. Okay? So here's the value. It would be 25 in this case. Does that make sense? I hope it does. The next thing I'm going to talk about is the nth term, A sub n. So A sub n is the value of the nth term. Okay, it might be the third term. What's the value of the third term? Bam, it's 35. What is the value of the fifth term? It's 45. So whatever number is in that slot, okay, that's the number. The value of it goes right in here. Okay, and the same thing right in here. The value of the nth term. It might be the value of the 1000th term. The value of the 50th term. Okay, whatever number that goes in that 50th slot is the number that goes right here. Okay, our next one is going to be n, which is very similar to the nth term. N is how many terms there are. So in this one, there's 1, 2, 3, 4, 5. So 5 would go here. Okay, the value of the fifth term, 45, would go here. Okay, do you guys see the difference there? 5 is the number of terms that there are, and the value of that fifth term is 45. Okay, and then our last one is this one right here, which is A sub n minus 1. So if the value of my fifth term goes right here, then the value of my fourth term goes in this spot, because A sub n minus 1 is the value of the previous term. If the value of the 20th term goes here, then the value of the 19th term goes right there. So it's always the value of the one right before it. So to kind of sum up those A sub n minus 1, A sub 1, Notice how whenever you have a subscript, so a sub n is the subscript, a sub 1 is the subscript, a sub n minus 1 is the subscript. Whenever you have those subscripts, those are values. Okay? So it's not talking about a term number, it's talking about a value of that term. Okay? So we'll talk about more about that as we go on, but I want you to understand that it's the value of it. Okay? Let's have another practice one. I know what a sub 1 is. So a sub 1 is the value of the first term. So negative 4 is what the first term is. That is its value. The common difference is a negative 5. So I'm adding a negative 5 to get each and every term. Write out the first 5 terms. Well, the first term is negative 4. The second term then is negative 9, adding a negative 5. Next one is a negative 14, then a negative 19, and then a negative 24. Okay, so you're adding a negative 5 to a sub 1, which is that very first term. All right, now we're going to start using our explicit formulas and our recursive formulas. Okay, so it says write out an explicit formula. An explicit formula, class, works in every single case for any term number that we want to find. All we have to do is fill in this information. Okay, so let's talk about these terms again, or these variables. A sub n is the value of the nth term. So how many terms are there and what's the value of it? Well, there's 1, 2, 3, ... I don't know how many terms there are. I don't know how many terms there are in this sequence. So I'm just going to leave it as a sub n. Okay? That equals a sub 1 is the value of my first term. We have a winner. It's 16/9. 16/9 is the value of my first term. Plus n minus 1. N is the amount of terms that there are. Again, how many terms are there? There's 1, 2, 3, 4, 5, 6. I don't know how many terms there are. It doesn't say that it comes to an end. So we're going to leave it as n minus 1. Times that common difference. Now the common difference can sometimes be a little bit difficult to find. I want you to talk through with me something really quick here. What if I had the sequence 2, 4, 6, 8, 10. Okay? How do you get from one term to the other? It's very simple. You just add 2 every time. To always find that common difference, what you can do, class, is you can say 2 plus what number equals the next one, which is 4. So how do you get x? You simply subtract 2. And you would get x equals 2. So this could work for any sequence. If I want to find D, I would say 16/9 plus what number, we'll call it x, equals 10/9. Well, how do you get your common difference all by itself? You would subtract 16/9, of course, right? So what is 10/9 minus 16/9? We go to our calculator. What is 10/9 minus 16/9? There's our common difference. It's going to be a negative 2/3. Our common difference is a negative 2/3. And if you ever want to check this, you could just continue. What happens when you add a negative 2/3? Bam, 10/9. What happens when you add a negative 2/3? Bam, you'd get 4/9. And you could check that as you go forward. Okay? So there's our common difference. We're going to write that in this spot, which is right here, a negative 2/3. Now let's clean this up a little bit because we can combine like terms. First, let's use the distributive property. So we're still going to have a sub n equals 16/9 plus, let's see, a negative 2/3 n plus 2/3. And then we can combine 16/9 and 2/3. 16/9 plus 2/3. And we get 22/9. 22/9 is what happens when you add 16/9 and 2/3. So we would get a sub n equals that negative 2/3 n plus 22/9. 22/9. So this is our equation for the explicit formula of this sequence. So this is going to give us the value of any term, class. This equation is now powerful. I could find the value of the 12th term, or I could find the value of the 100th term. Or proceeding on to our letter B here, I can find the value of the 20th term. Okay, what is a sub 20? Well, I know that a sub n is a negative 2/3 n plus 22 ninths. A negative 2/3 n plus 22 ninths. Well, if I want to find a sub 20, that goes right there. What is the value of the 20th term? I don't know. I'm going to take a negative 2/3 and I'm going to multiply it by n, which is the amount of terms that there are. When I come to a stop, it's the 20th term. So I'm going to multiply it by 20. That plus 22 ninths. So this one now, the rest of the work we can do in our calculator. A negative 2/3 times 20. A negative 2/3 multiplied by 20. And then I'm going to add 22 ninths plus 22 ninths. And I get the value of a negative 98 ninths. Negative 98 ninths. A sub 20 equals a negative 98 ninths. A sub 20. So what did you just find here, class? You found, here's the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, all the way up to the 20th. If you were to continue adding a negative 2/3 to get to each and every term, the value of that 20th term would be a negative 98 ninths. If you're bored sometime and you want to add a negative 2/3 20 times, see if you get a negative 98 ninths. I guarantee you will. Okay, so that's what you find when you do that kind of problem. All right, now we're going to use our recursive formula. Okay, so this is basically a way that you can systematically show your work. It's very beneficial, but a lot of math students don't like to show their work, so they don't like doing this very much. But keep a positive attitude about this. Let's make the best of it. Write a recursive formula, which here it is. So what is a sub 1? The value of my first term is 16 ninths. So the value of my nth term, a sub n, is the value of the term before it, which is a sub n minus 1, plus the common difference, which we know to be a negative 2/3. Okay? This is the same sequence as on the last one, and that common difference was a negative 2/3. So this is your answer for a recursive formula. Okay? So this will always work to find the nth term as long as you know the term before it, which is a sub n minus 1. So class, here's where we need to start. We know the value of the first term. We know the value of the second term. We know the value of the third term. We don't know the value of the fourth term. So we got to start off by saying, a sub 4, what are you? Okay? Well, here's how you find a sub 4. Let's put that in right here. A sub 4 equals a sub 4 minus 1, which is the value of the previous term, which is a sub 3. What is a sub 3, or what's the value of the third term? Aha! It is 4 ninths. So the value of the previous term is 4 ninths plus the common difference, which is a negative 2/3. Class, what is the value of the fourth term? You can do that in your calculator. 4 ninths plus a negative 2/3, that number is a negative 2 ninths. Negative 2 ninths. Well, we need to find the sixth term. But before we can find the sixth term, we need to find the fifth term. So what is that fifth term? Well, a sub 5 is found by taking a sub 5 minus 1, which is a sub 4, the value of the previous term. What's a sub 4? We found it right here. It's a negative 2 ninths. So it's a negative 2 ninths plus a negative 2/3. So what is the value of the fifth term? The value of that fifth term is, doing that in your calculator, a negative 8 ninths. A negative 8 ninths. All right, and now we're here. We need to find the sixth term, so here it comes, a sub 6. What is the value of a sub 6? Well, it's found by taking the previous term, which is a sub 5, which we found to be a negative 8 ninths, plus our common difference, which is a negative 2/3. So a sub 6 is what number? A negative 8 ninths plus a negative 2/3, and that's going to be a negative 14 ninths. Negative 14 ninths. So this is how I expect you to show your work on our worksheets and on our test, okay? So you have the third term, so next find the fourth right here. Next, find the 5th right here. Finally, find the 6th right here. Okay? Make sure you show your work in such a way like that. All right, next one. This one is a very interesting problem. Our common difference, again, is a negative 2/3. Same sequence. So if I keep adding a negative 2/3, negative 2/3, negative 2/3, negative 2/3, if I keep on adding this, eventually I'm going to get to the negative 149ths. What term number is that? Okay, so I know the value of my first term. I know my common difference. I know the value of my nth term. The value of my last term is a negative 149ths. I just don't know what term number it is. I don't know how many terms there are. So this is my variable. N is what I want to find. Okay? So let's do that. A sub n, which is the value of the last term, or the value of the nth term, is a negative 149ths. That equals a sub 1, which is 16/9, plus n minus 1, which we want to find what n is, n minus 1 times the common difference, which we said was a negative 2/3. So now we're just solving an equation. We're going to solve for n. First thing I'm going to do is I'm going to get rid of this 16/9 by subtracting it. A negative 149ths minus 16/9. A negative 1/149. Subtract, was it 16/9? Subtract 16/9. And I got a negative 52/3. A negative 52/3. That now equals n minus 1 times a negative 2/3. So the next thing I'm going to do is I'm going to divide by a negative 2/3 to get rid of that coefficient. Divide by a negative 2/3. So we'll do that. Divide by a negative 2/3. And I get a positive 26. So I get 26. That equals n minus 1. And lastly, getting n all by itself, I simply add 1. I add 1. So how many terms are there in this sequence? N equals 27. A negative 149ths is the 27th term in this sequence. So if you were to have your first, second, third, fourth, fifth, sixth, seventh, this one would be the 27th term. That would give a negative 149ths. All right, last problem. Let's get a little bit of backbone behind why we do this stuff. We're on a vacation or something like that, and we need to rent a vehicle to tour around the city wherever we're at. And in this one, we're going to rent a Dodge Viper for N days. We don't know how long our vacation is just yet, but let's write an explicit formula, okay, for the number of days that we rent this Viper for. Okay, so our formula is going to be this: a sub n equals a sub 1 plus n minus 1 times the common difference d. This is our explicit formula. Okay, I don't know how many days the vacation is yet, so let's just call it n days. A sub n equals the value of the car for the first day. It costs $799 to rent that Viper for 1 day. Whoo! Little steep. $799 plus n minus 1. We don't know how many days we're renting it for just yet. Times the common difference. So how do I get that common difference? What do I add to go from here to here? $799 plus $799 plus what number? That common difference gives us $12.98. Well, it's $12.98 minus $799. $12.98 minus $7.99. So $499 is that common difference. $499. And as you can see, you're going to add $499 each and every day, each and every term. So this is an arithmetic series sequence. So that common difference we said was $4.99. So now let's clean up our formula a little bit by distributing this. So a sub n equals 799 plus 499n minus 499. So now combining like terms, 799 and minus 499 is a positive 300. So a sub n equals 499n plus 300. If I'm taking a vacation, this is going to help me using this formula to plan on how much money I'm going to have to spend on this Viper if I rent it for a certain number of days. Okay, this formula right here. So using that, it says, how much would it cost to rent the Viper for 14 days? So I want to be gone for 14 days on this vacation that I have. 499n plus 300. Well, a sub n equals 499n plus 300. There's my explicit formula. So if that's the case, if I'm going to be gone for 14 days, a sub 14 equals 499 multiplied by 14 and then adding 300. So let's do that in our calculator. 499 times 14. 499 times 14. And then I'm going to add 300 to that. Woo! $7,286. That's how much it costs to rent that Viper for 2 weeks. Man. $7,286. $7,286. Okay? Little steep. Maybe some of you guys have that kind of pocket cash. I don't know. Now, let's say we're going on this vacation and we have $5,290 to spend to rent on this car. How many days can we rent it for? Okay, so I'm coming in with a strict budget. I can only spend $5,290. How long is my vacation going to be? So what I have, class, is I have the value of that last term. So in our equation, a sub n equals 499n, I think it was. 499n plus 300. So if I know the value of my last term, the value of my last term is 5,290, that number goes right here. So 5,290, that equals the 499n plus 300. When it says how many days can I rent it for, I want to solve for variable n. So I want to get n all by itself. So I'm first going to subtract 300. If I subtract 300 from both sides, I now end up with 4,990. That equals 499 multiplied by n. And then lastly, I divide 499 by both sides. And I get n to equal 10 days. So my vacation is going to be 4 days shorter than my other one, but I'm also going to save a little bit of money. So my vacation is going to be 10 days long to rent that Viper. Okay? Our Excel math objectives for tomorrow are going to be objectives 117, 118, and 119. Be sure to let me know if you have any questions on this as you move forward.